Welcome back. It seems quite appropriate to move the discussion toward the bigger picture of how a utility gets from proof of concept to enterprise-wide adoption of an AI solution. Our next panel will share examples of how AI solution providers can support utilities with application and adoption, and examples of utilities that have taken to developing their own solutions in-house. I'm very excited to turn it over to R&D Innovation Director Heather Feldman, who is EPRI's director sponsor overseeing our artificial intelligence research, as well as nuclear plant modernization and other digital transformation activities. She's going to lead us through a great conversation with panelists from McKinsey and Company, CPS Energy, Amazon Web Services, and Exelon. Heather?
Thank you so much, Christine. It's my pleasure to be here today with Rolando, Peter, Pedram, and Ankush. I'm here in EPRI's welding lab, and I'm sitting next to our proof of concept for adaptive feedback welding using machine learning. The concept here is to use sensors as well as robotics in real time as a weld is being made, so that we can determine whether or not a defect is being produced in real time and make a correction. The data that's being collected includes an image of the weld pool using a camera. It includes microphones, listening for that sizzling bacon sound. If you've ever welded before, sizzling bacon is the sound that you want to hear to know that you've made a good weld. And we have other data sources that are integrated together to really determine whether or not a good weld is being made. So this is a proof of concept that we're working on today. And as we think about how do we get from proof of concept to enterprise-wide solutions, that's what we're going to talk about today. So our big question is, how do we go from a proof of concept like adaptive feedback welding that I'm sitting next to something in a large scale, something that's enterprise-wide? So it's really my pleasure to introduce our first speaker today. Our first speaker is Peter Safarek. He is a partner at McKinsey and Company. He has served clients primarily in basic material and energy sectors in the United States, as well as Africa, Middle East, Central Europe, and Russia. He has worked in onshore wind, offshore wind, solar, and coal. He's recently authored 2 papers on digital power plant. One is titled Unlocking the Value of Digital Operations in the Electric Power Generation. And the second is titled Power Plant 4.0, Embracing Next Generation Technologies for Power Plant Digitalization. So Peter, over to you.
Thank you, Heather. It's a pleasure to be here. Let me share 2 stories about adaptation of AI on an enterprise level scale, one that worked and one that didn't. But before we do that, I assume that we all love data. And I assume also our audience loves data. And we can look at one source of it, which is World Economic Forum, that has established Global Lighthouse Network, which is a network of sites or plants that have implemented the 4th industrial revolution at scale. And in our case, the 4th industrial revolution can serve as a proxy for AI advanced analytics. And they have done it, they started in 2018, in order to support the industrial sector, which was recognized as a little bit lagging behind other industries. When we look at the number of sites in 2019, there was like 50 sites or plants, but none of them was electric power company. There's a report being released this week, and there's now already 90 such sites, plants, and there's already a first electric power company. This acceleration in adoption at scale reflects also my personal experience. 5 years ago, we have developed together with a client algorithm for predictive maintenance for particular equipment of a large coal-fired power station. And it mattered because that equipment was responsible for significant unplanned losses of availability. And we've got a great algorithm, we've got a great model, but it didn't scale up. It didn't scale up to other power plants or through the organization. In retrospect, Why? It had a couple of reasons. First of all, we didn't build it to scale up. We kind of built it to the particular case. We didn't also involve the operation and maintenance people. We worked with the engineers and data scientists. And lastly, we didn't create it in the organization capabilities to retrain model once the operating condition has changed. Fast forward 2 years ago, I have worked with a large US renewable player. And they started their journey and rethinking their operating model. And very soon, they have figured out that they need a lot of AI and advanced analytics to make a step change. And they did it in having algorithms for maintenance prediction, for maintenance needs. But then they had a complex optimization of assets, of tasks for the assets linked to scheduling of crews. Look at that end to end. And they did scale it up across 30 sites. So what was present was all those elements that we missed in the part. It was the leadership, the management, who was essentially on hook to deliver performance improvement. It was working with the operation and maintenance in the field, having adoption in mind. It was thinking about the scale up from the get-go. So the data, my personal experience, shows that this adoption is accelerating. I'm really happy to be here today to discuss what are the ingredients that make this successful. Back to you, Heather.
Thank you so much, Peter. That was great. I loved both of those stories, and I know we're going to dig into those in just a few minutes. So I'm going to hold my questions for a little bit. What I'd like to do now is introduce our second speaker. Our second speaker is Rolando Vega Avila. He is Interim Director of Enterprise Advanced Analytics at CPS Energy. He has led analytics staff development and contributed to the creation of a brand new department called Enterprise Advanced Analytics. He's also worked on new technologies, including outage prediction and vegetation management. Prior to his current role, he worked at a university. He was director of research at the University of Texas at San Antonio, where he led the R&D and product delivery in subjects of renewable energy forecasting and smart grids. And he's also had a consulting role. He worked in renewable energy business in the US and Latin America for ABS Group. So Rolando, we're so glad to have you today, and I'll turn things over to you.
Thank you, Heather. It is my pleasure to be with you all here today. And I think that the way that I'm going to characterize, my introductory comments is in the way of three parts to a story. The first one is, and it's really going to be a journey over the last 4 to 5 years. The first one is in regards to how we started in our journey understanding big data and governance. That's the first component I want to address. The second one is the challenges that we have encountered in our operating model. And then the last one is, now that we have, had some experience and we have found some of the things that work and don't work, where do we go from here? What are some of our next steps? And so in regards to the first element of our story, in our development of knowledge and understanding of how to leverage AI technologies and move from the proof of concept to adoption, understanding big data, what do I mean by that as the first component? We first went to identify some of the most critical data assets that we characterize as being heavily underutilized or leveraged. And we wanted to have a pertinent infrastructure that would allow us to not only ingest, but move that information for analytical purposes. And I'm referring to specifically things like weather information at scale distributed over all of our city of San Antonio, Texas. Clearly, the next one, the big one, is the AMI infrastructure. That information we have been collecting into the analytics platform for years now. And then outage information, because our senior leaders consider the reliability, to be a very critical element. And so our analysis around outages was an imperative for us. we realized that the pi information, for example, from our power plants and the grid itself was a good big data set, but actually was quite mature in terms of the friendliness to retrieve information. And so we were quite comfortable in our journey to understand basic data flows, but data flows that operate at scale. As we first look at the infrastructure, we noticed that we put a lot of focus on scale. And by scale, I mean that we could do distributed operations, and we can manage and maneuver, not only prepare the information, but train models with hundreds of thousands, if not millions of channels, and billions of records. And so we got good in managing the data at scale. However, we did not define the elements of latency, which is how quickly you need to have this information. However, we did have a platform, and the platform allows us, to have storage and compute power to flex, our ability to deploy a variety of use cases, which seem to be an important element for our company, as otherwise we would have to come and present a brand new architecture for every single case and use case that we developed. And the last piece in our journey of learning was security and data governance. We did spend a tremendous amount of effort to make sure that the user access to these centralized data assets were properly governed, and defining Active Directory roles, for example, and role-based roles. And that was a very key element in our journey, as well as understanding how do we adopt existing legacy ways of doing business, developing new technologies. So the whole thing of dev, QA, and production, we adopted, we embraced everything that the company had already been doing for a long time. That brought us to the challenges. And I'll start right there with that element of embracing what the company has, and does that work going forward? Initially, we were focused on batch operating batch processes for ML and AI workflows. So we realized that we needed to have, if we needed a use case that required latency, better latency, or low latency, then we needed to have a whole architectural discussion, because we didn't account for that in the beginning. So what happens every time you introduce a new architecture? You have a lot of effort, people, and justifications that you need to be providing, and clearly, that takes a lot of energy from the organization. So business applications are usually created by vendors that create, very customized solutions for very specific problems. But how do you scale that from a platform that serves just one problem to a platform that scales to many problems? At the end of the day, the main challenge is that customer experience is king, and not everyone cares about the amazing work that is happening behind the scenes. They just want an answer. And so as we go to define new use cases, how do you define new opportunities? How do you communicate these opportunities, and how do you prioritize them so that you're not in the mode of putting out fires every day, trying to do something, or just doing whatever is in front of you? And the last element, which I echo in regards to what Peter mentioned, the element of people, change management and adoption, tremendous things. And the next question is, are we using them? Are they generating the value that we originally anticipated to create? And so a great deal of focus needs to be placed on these. We usually focus on technology, but I think that we need to put some effort to not go into the IT-OT convergence, but really think in terms of the human IT-OT convergence. I don't think that there has been nearly enough focus on this area. So where do we go from here? Data strategy, clearly articulating data governance and establishing, for example, the data catalogs, data owners, master data management, and an API strategy that enables not only internal consumption for development, but also third-party vendors and partners that we can create and innovate along the way. So with that, I will turn it back to you, Heather.
All right, very good. Thank you so much, Rolando. I really like that last comment about putting the human at the center of this all. And I know we'll get into that conversation later on. I'm going to go ahead and introduce our next speaker. We have Pedram Jahangari from Amazon Web Services. He is an enterprise solutions architect. He has hands-on experience of all aspects of advanced analytics for building quantitative and large-scale solutions for the enterprise by leveraging cloud solutions. He previously worked at National Grid, and he worked in their quantitative analytics group. Pedram, so glad to have you with us today, and I'm going to turn things over to you.
Hi, Heather. It's a great pleasure being with you and all the speakers. And also, good afternoon, good morning, good evening, whoever listening to us. I would like to start my talk with basically one of our prime AI ML example from POC into enterprise wide. Let me just advance. Okay. From one of our AI/ML prime example, which basically started from POC to enterprise-wide AI, which is Woodside. It's an Australian oil and gas company. They did a very interesting shift. This was basically for liquefied natural gas or LNG, and the issue is when LNG foams, you pretty much lose control. All of your valves are assuming a liquid going through, and suddenly you have this liquid and gas mixture, and everything breaks apart. So in our discovery discussion, basically with Woodside, one of the operators indicated that he can hear when a valve is about to foam. And we tested that basically we were able to prove out basically in six weeks we were able to see yes, with a very low cost acoustic sensor you can detect if a valve is about to fall, and it does it early that they can take an action. So today they are doing 3 million daily calculations with 6,000 different models, which is running and using their 200,000 sensors in their LNG plant, which is massive. This was an enterprise level example enabled with the power of cloud and ML, and they can analyze their massive data in real time at very high scale, so they can prevent basically their plant shutdown with the help of IoT and ML. Next slide, please. So there are multiple strategies to adopt AI and ML, depending on several factors, including resources, time, and budget. We have divided the ML adoption strategy into 3 layers of a stack. Each layer has a broad and deep set of machine learning capabilities for builders at all level of expertise. At each layer, the main goal is to remove the undifferentiated heavy lifting, so enterprises like you can focus on what matters basically. The bottom layer is basically the framework, interfaces, and infrastructure for expert ML practitioners that they want to build their own models from scratch. At this layer, there are 3 core basically frameworks that are predominantly used, such as TensorFlow, PyTorch, and MXNet. But on the other hand, there are not that basically many expert ML practitioners. So if you want ML to be pervasive in your company, you have to make it easier for everyday developer and data scientists to build ML models. So we are introducing the middle layer, which provide data scientists the ability to build, train, and deploy their models at any scale. It basically removes the complexity from basically the every step of machine learning workflow that you have. And then you can work on any type of use cases, for example, predictive maintenance to computer vision, or even predicting customer behavior. Our experience shows that enterprises achieved almost 10 times basically improvement in data scientist productivity using this strategy. But now I just want to talk about the basically the top stack, which in my opinion is the easiest and more straightforward way. This is for the companies that who want to add purely solution oriented, and they don't want to build their own models. There are fully managed pre-trained API that they can leverage, and examples are on vision, speech, text, fraud detection, building chatbots, personalization for recommendation engine, forecasting that I'm going to talk about that, enterprise search, contact center if you have basically a customer service, and machine basically the equipment monitoring to detect the abnormal machine behaviors, and so on. Let's talk about one example that I think it's of these API pre-trained model that I believe it's a good use. It's useful for actually powering utilities. Next slide, please. So among all these APIs that I talked about, the pre-trained model, I would like to talk about one of them, which is Amazon Forecast. This forecast service basically puts the power of Amazon.com deep experience in forecasting into the hands of anyone who do not have any machine learning experience. It is fully managed service that uses basically machine learning to deliver very high basically it's delivering a highly accurate forecast. And as shown in this diagram that you're seeing, you as a user input your historical demand data into the service. The service then automatically sets up a data pipeline. It ingests the data, add built-in data sets such as weather, then trains the model on your data and generates forecasts. And for you, by automatically using different algorithm, it will identify which algorithm works best for you and provides the highest accuracy. With all of this work that are done behind the scene, you get a very accurate forecast, and you're saving basically resources by not hiring or allocating a dedicated basically data scientist to build and maintain your own in-house model. I personally was surprised that actually you can add a built-in weather feature that incorporates historical and projected weather information into the model without the need that you provide the input. So later on the talk, I would love to actually talk about some of the examples that we had success on this strategy, but I would like to have a pause and turn it back to Heather.
That sounds great, Pedram. I really appreciated your remarks there, especially thinking back to what you said in the beginning about the natural gas plant, where the operator could walk by and hear something wrong with the valve as the flow was going from a liquid to a vapor and a liquid. It's very similar to what I was talking about with welding and in hearing that sound of sizzling bacon. So I think there's some analogies with that type of a setup there and how AI can be used. So we'll get back to some of the topics that you just mentioned. What I'd like to do now is introduce our next speaker. Our next speaker is Ankush Agarwal. He's Director of Grid T&D at Exelon. I'm sorry, Director of Grid T&D Analytics at Exelon. He is responsible for collaborating with business leaders and experts across the Exelon family of 6 companies to develop and deliver a robust grid transmission and distribution analytics capability and program. He's also co-founder of Exelon Utilities Analytic Academy program, which I know he's going to talk to us about today. So Ankush, over to you.
Thank you, Heather. Good afternoon, all of you. Thank you for inviting me, Heather, to this forum to discuss how analytics and AI will be a key driver of the utility of the future and the importance of scaling this to enterprise-wide adoption. I have had the pleasure of working for Exelon for the last 11 years. And so for those of you who are not familiar with Exelon Utilities, our 6 utilities serve 10 million electric and natural gas customers, the most in the United States. And we have a combined service territory of over 25,000 square miles across Delaware, Washington, D.C., Illinois, Maryland, New Jersey, and Pennsylvania. We are investing over $27 billion in our utilities through 2024. I wanted to share this with you because when you see the scale of our company, it becomes increasingly clear that analytics, AI at scale and scalable solutions will play a key role in the utility of the future. In the next slide, I'm sharing over here. I wanted to use this to sort of showcase a few examples of how artificial intelligence will be used in utilities of the future. The first example is around, distributed energy resources, DERs. For most utilities, the short-term planning horizon is 5 years because it takes 1 to 3 years to build a new circuit, 2 to 5 years for new substations, and potentially even longer for transmission systems. Distributed energy resources and electric vehicles will significantly change the load profile of the systems. And when you think about it, when a customer buys a new car, they don't give the utilities a call to say, hey, I just purchased a new vehicle. And so certainly when they are purchasing an electric vehicle, we don't expect that to change either. So building solar and EV propensity models will allow utilities to anticipate those changes and understand which customers and communities are most likely to be EV drivers. And based on that load profile today, we can determine, which customers may also already own an EV vehicle. So using artificial intelligence, this really allows us to understand where do we need to build the necessary infrastructure so that we can do that and start planning for that as soon as possible. Another example I wanted to use is around vegetation management and how do we harden our system. So managing vegetation is one of the highest priorities for utilities, not only because it is a costly activity, but also because it has a huge impact on the reliability of our system. Vegetation causes outages. Vegetation outages account for about 24% of the outages at Exelon Utilities annually. And it is the single largest outage cause. So improving it has a huge impact on our reliability performance. So by using reliability data, outage data, and then combining that with image detection AI on satellite images, which are becoming increasingly available at good prices, we can determine the relative vegetation risk of circuits on the system and better plan hardening of our systems. A few other examples on the slide are around risk-based predictive maintenance to predict failures. There's also a call out on how we can use and build marketing models so that we can increase community solar adoption. And I just wanted to call out that this slide, when my friends look at it, they sometimes think of this as a scene from like Steven Spielberg's Minority Report. And I can promise you, a lot of this is here, and the future is here already. So before I turn this back to Heather, I just wanted to make it a little bit more real by sharing this slide, which sort of showcases a snapshot view of how Exelon Utilities and my team uses the data within Exelon to make some of these use cases real. On the left, you see some of those source systems we target. GIS, asset management, work management, AMI, and weather data. And then you see the use cases I discussed around veg management. There are others around storm readiness. And then we use this to talk about predicting storm damage, identifying high-risk circuits. And so, I just wanted to share this with the group so that it sort of puts into perspective how all of this data comes into play. And I'm really looking forward to the conversation on how do we use all of this, how do we scale this here today. With that, back to you, Heather.
Thanks so much, Ankush. And I really appreciated your remark there about the future is here today. And it really feels that like that to me as well. All right, so we've each shared a story or two about artificial intelligence, proof of concept, scaling out to enterprise-wide AI. So now we get to dig in and have some fun and really learn how to make this happen. What's the magic behind going from a proof of concept to enterprise-wide scale AI? So I want to start and just reflect back on defining what we mean by enterprise-wide adoption of AI. So what does that picture look like? Let's put our heads together and really paint the picture of what enterprise-wide AI looks like. And Rolando, I'm going to start with you. So paint that picture for us. What does this look like when we really get to enterprise-wide scale?
Thank you, Heather. So I think that it's a picture where people can focus on the jobs that only people can do, and the definition of the problems that we need to address, and we let machines do what they do best, which is the repetitive activities, and to deal with the volumes and the speed of information, and the diversity of information. As long as we clearly delineate the proper governance and security for the information to address whatever boundaries or constraints we have for each data set, data source, and the corresponding data owners who define or help us define those policies. If we have those boundaries well taken care of, I think that we would really free a very, very powerful engine. It's like a super brain that would really be the composition of groups of people. Instead of one individual doing the analytics on a given department, it would be like a group of 10 to 20 people doing the task at a very small fraction of the cost. So again, it is really a matter of efficiency, and maybe not yet, at least on the extreme events. I think that AI has some maturation to do on identification and prediction of extremes, but on the day to day, is the $1,000 repeated thousands of times, and the amount of money that will bring at the end in savings or additional revenue. And also, of course, the customer experience is king. So that better customer experience by really customizing solutions for what they want and what they need.
All right, very good, Rolando. So now I'm picturing a super brain that is well integrated across the organization, bringing data and information together. I think that's a fantastic picture. You've also talked about customer experience, so making sure the customers of your utility organization are having a really positive experience, and it's all enabled by AI and machine learning at this enterprise-wide scale. So let's go from a utility organization over to you, Peter, who's at a consulting firm. So how would you define enterprise-wide AI?
So Rolando's picture or vision is great. I really love it. But that's kind of a vision. It takes some time to get there. So thinking about electric power companies, it's no different than other companies, and we would typically want to see a couple of characteristics in place. The one is that there are use cases in place that deliver impact. So it's not only about the proof of concept, but there's tangible benefit, and they are scalable. And we heard a couple of examples of this 3,000 or 300,000 sensors. That's a scale that kind of gets you where you need to, and it might be across geographies, it might be across assets, but there has to be scalability. So impact, scalability, and then integration of use cases. And I was listening at Ankush's slide with kind of all this kind of the first column of all the different use cases, and there was almost integrating into an insight. So that's the integration that we want to see. And there are two more elements that need to be in the place. One is the technological platform, and Rolando provided an excellent picture of what that might look like. And the last element is the capability of the organization. And that's both on the talent, like once you have all these ML AI model, who will be retraining them, who will kind of maintain them, but it's also the way that how organization delivers the new use cases. So in a nutshell, the vision is great, let's go there, but I would give a credit to organizations that have these characteristics in the place and kind of are building them as kind of enterprise-wide adoption.
Thank you so much, Peter. So I'm now envisioning individual use cases that are both impactful, scalable, then integrating those use cases up and sort of building up to something even bigger. We've got a technology platform, and then you're pulling in the people. So we have to have the data science expertise. We have to deliver it in a way that connects with, I think it was, who was it that was saying earlier? Peter, it was you saying earlier that at the plant, the people have to understand the technology in addition to the data scientists creating it. So you've painted a really good picture of making that happen. So Pedram, I'd like to turn things over to you and hear about enterprise-wide AI from your perspective at AWS.
And thanks, Heather. I'm listening here, and actually I enjoy what basically my basically peers just shared. I just want to say that we've all heard about this technology and described a number of ways, and I just want to have it take a step back and level set what basically they mean. So when we say AI is basically is a way to describe any system that can replicate the tasks that previously required human intelligence, and almost all these AI systems today are basically created using machine learning, which uses large amount of data that, as you already basically mentioned, and basically to create and validate a decision logic, which is known as model. And deep learning is basically a type of these machine learning that uses a technique known as basically deep neural network. So to me, a best use case for enterprise AI or ML problem would be that a problem that has three requirements. One is reaching the data, then it's impacting the business significantly. Third, and it hasn't been actually solved well today. So if we have such a problem, it's a very good candidate to use AI and build an enterprise AI. If we have a problem that might be reaching the data, but it doesn't have a business, it doesn't have an impact on the business, probably not a good candidate. And we're talking about electric utilities today. There are and also Ankush mentioned it's not future, it's today. We have utilities that they are using AI for automated inspection, it's preventive maintenance, demand management, load forecasting, theft detection, that they could basically completely raise their earning before basically interest, tax, and depreciation by 20 to 30%. Yeah, back
That's a
to you, Heather.
wonderful. Yeah, thanks. I think that's wonderful. You've created this trifecta, this triangle in my mind. So you have to have something that's data rich. It has to be a pain point for the organization and bring value. And it has to not be solved very well today. I think that's a wonderful triangle of thought process that people can use as they're thinking about what can make an impact enterprise wide. Wonderful. So now I would like to hear from Ankush, another utility organization. So how would you define enterprise-wide AI?
So I think Rolando, Peter, and Pedram have really done a good job of sort of defining what enterprise AI is. I loved how he talked about the big brain and the customer focus, the definition. So those to me resonate really well. I made some notes of like things which I want to see, and when I think about enterprise AI, they were very similar to what Peter said, but I'm going to just sort of lay them out just in case there's some sort of small nuances. So when I think about enterprise AI, what comes to mind is, this cannot be a one department is driving it. This is not an analytics organization driving enterprise AI. It's a top-down leadership support driving in and getting the buy-in across all business units, because every single business unit across the utility needs to be part of the conversation and adopt AI. So I think that's critical. When I liked what was talked about in terms of bringing all this data together. I'll take it a step further. there are so many critical elements of data which are unfortunately for all utilities still stuck in one-off spreadsheets, and people are making key decisions off those spreadsheets. And if we really want to have machines make decisions, which for us, it's very important that we pay attention to moving those spreadsheets and that information to single sources of truth, so that we can build these platforms at scale as accelerators. So I think that's the big second thing. The third one is, I know we talk about scale, and scale usually implies a big bang approach. So really want to emphasize that even though we are saying that it should be enterprise scale, it's super important that we still follow a mindset of agile, that we allow people to fail fast, be flexible. And in the AI space, what we have found is that unlike a software deployment, it's not going to be a one time and done. You don't just deploy like a software and go home. It's an iterative process where you deploy something, you get feedback, and you improve it over time. And so there's this thought process of stakeholders need to be prepared for a journey. When they talk about artificial intelligence, it will start off with being supporting their thought process, and then over time, as it learns, start to do that. And then I'll end with saying, and everybody sort of said this, but it's very important, is our most valuable asset is our employees. And so we need to prepare our employees to leverage these AI solutions, not as black boxes, but empowering them to ask the right questions during development and providing them feedback to drive better results. If we are focusing, I think it's super important that our utility employees who know the business the best challenge what's being developed, because it's not easy to develop and there are many ways to go wrong. So I think that's really critical. So you'll hear me talk about that again and again, Heather. How do we prepare our employees for that? So I hope that was helpful in sort of painting a picture of how we need to broadly think about AI, not just in terms of software, but in terms of people, process, and technology.
Yeah, you did. You painted a fantastic picture between people, process, and technology. And each of you have touched on the why we need enterprise-wide AI throughout this conversation. But I do want to take just a few minutes and really hone in on that, because I think it's really important. It's the driver for why we're going to go do this. So Ankush, while I'm still with you, let's talk a little bit about the why. Why are we trending towards enterprise-wide AI?
Yeah. So I think the answer I'll give you on that will sort of the why doesn't really have an AI component to it. It's just the fact that at Exelon Utilities, our story is always going to be focused on our customers. We're trying to figure out how we can support our diverse communities, their economic health, providing them clean and affordable energy choices. And we know that to do this, we need to modernize our energy infrastructure. We need to make it more safe. We need to make it more reliable. We need to make it more resilient. And with COVID and everything happening, we know that our customers are staying at home. They need access to even more reliable electricity at home to be more productive. And so when you start thinking about all of those things, it becomes clear that we need to invest in the grid to be more flexible. So when I was talking about the ability to integrate distributed energy resources, we talked about new load profiles. It's clear that you need to think about AI. When we are talking about resiliency, we're talking about how do we prevent damage and recover as quickly as possible from major weather events. It seems that these weather events are happening more and more often. So we need to think differently about this. So that's where AI comes in to look at past weather events, how they impacted our system. is the impact becoming stronger? Is our system becoming more resilient? So AI plays a big role there. I talked about the $27 billion we are investing and how big our company is. And so all of those things just come down to, the benefit of AI is that it's going to be one of the tools in our tool belt to sort of, get to that solution and help us deliver for our customers.
Yeah, that's great. That's great. So from your perspective, it's really all about what drives your core business. And I'm hearing you say AI is a tool in the toolbox that helps you meet those end customer needs, and it helps you meet the demands of the grid today and the grid of the future. So sticking with the theme of a utility perspective, I'd like to transition over to you, Rolando, and hear your perspective on why artificial intelligence and why enterprise-wide.
Well, thank you, Heather. I will start by, some time ago, I took a training in customer journey mapping and customer experience, and he had shared something with us that I think was important. In order to know whether you are exceeding expectations, you need to understand what are the expectations in order for you to meet them and to exceed them. And sometimes when we're solving for AI problems, we are very likely solving and optimizing for solutions that way exceed customer options, because you just haven't had the opportunity to properly define the problem. And so when I look at the why AI is because there is so many opportunities to really wow our customers, not just meet their expectations. That's the first reason. There are way too many opportunities to wow the customer. And number two, I would say that customer expectations are changing, and they're changing very, very rapidly, way faster than we would like to admit at times. And of course the utilities is a little bit playing, actually in a big way, we're playing a catch-up game, because we have the way that the customer is connecting with their mobile devices and with their computer has dramatically changed, and the definition of what we do as customers has changed. And so I think that they don't make a distinction of what is the industry that they're engaging with. They just expect better service and more customized solutions. And so overall, that requires that we are more optimizing what we do, that we reduce our costs, that we continue to be reliable and resilient, as Ankush mentioned, and safe. But on top of that, we need to continue to innovate. And AI is just a formidable opportunity to innovate. It's in a way, a low-hanging fruit to leverage on. Back to you, Heather.
Okay. Very good, very good. Thank you, Rolando. Peter, I want to turn to you next and hear from your perspective, more of a consulting perspective. So what are you hearing and seeing with the organizations that you're working with?
Thank you, Heather. There's no choice. The electric power sector is in the midst of two revolutions. It's the fourth industrial revolution, and it's the energy transition. And on both have been touched. So the first one, Ankush mentioned the reliability, resilience. We heard about the customers from Rolando. I would just add some. There will be pressure from regulators to actually apply these solutions to kind of reduce the rates or kind of mitigate the increase. There will be expectations of your own talent of using these tools. So in the same way as the bar for customers is rising, is the same for young employees. And last but not least, and it should have been the first, there's a big health and safety implication, because now we can have more granular understanding of the drivers of risks. So these are all good set a long list of reasons for the fourth industrial revolution, or kind of what's happening. And in addition to that, there's energy transition. Like, we don't know what the future will be, or we have a hunch, but we don't know exactly. But it will be definitely much more based on technology. And also, there are new competitors coming, many of them from the technological angle. So it's a perfect turmoil, and I don't think there's a choice.
Yeah, thank you, Peter. Thank you, Peter. I think that's wonderful. I love that you pulled in the perspective of health and safety, as well as these are the tools that university students today are being trained on. And when they enter the workforce, this is what they're going to expect from future employers. So that's another really good point as well. So, Pedram, what are you seeing from a, I'll say, a platform provider perspective in terms of the why?
Yeah, actually, this is a good question. So I think about, so we're talking about electric utilities today. There are 3 Ds basically that are changing today utilities: decarbonization, decentralization, and digitization. We used to have deregulation. That's gone now. So if all these are the key enablers for these 3Ds and innovations are basically AIML. If the electric utilities wants to differentiate, the AIML is the key enablers. I would think about as far as the advantages and benefits, it can basically has potential impact on multiple fronts. It could be improving existing products or basically new ones. You can think about that. It creates a greater efficiency. How? Through demand planning, through a more accurate forecast. It makes basically a more informed and faster decision, so you can act basically on opportunities much faster and you can get a better results. It Because AIML, it leverages data to develop a revolutionary ideas. You can bring new products to the market, and also it enriches your existing products. If you have a forecast today, you can really increase basically the performance of your model or whatever analytical engine that you have. And of course, it's basically utilities are coming to some competition, so it attracts new basically customers, and it will bring more customer engagement. And also, I mean, the way that Peter mentioned, so there is no way around. Based on the IDC recent survey, 40% of the basically digital transformation initiatives will take advantage of AI. By the end of 2021, they said that actually we are going to have almost $50 billion spent around the world on just AI. And also, I remember Accenture had a very recent survey, and it shows that 42% of the executives say that AI will drive basically innovation in their organization, and they have already put that into their strategic plan. Yeah, back to you, Heather.
Yeah, thank you, Pedram. Those are all very, very good remarks here. I tell you what, I could spend hours talking with all of you. This has been fantastic. And I know we only have about 5 or so minutes left. And I do want to spend some time talking about the approach to getting to enterprise-wide deployment. And I'm also looking at the questions that are coming in from the folks that are out there with us today. And there's a lot around culture. There's a lot around what does the future look like in 5 to 10 years, and there's a few around challenges as well. And I think these all kind of come together under this approach theme. So I want to spend the last bit of time that we have today really talking about the approach to getting to enterprise-wide deployment. And Ankush, I'd like to start with you. I know we've previously talked about the university that you've started there at Exelon. So I'd love to hear more about that as part of the approach.
Sure. I can cover that. So while we are hiring and leveraging some of the country's leading data scientists to lead the way we develop AI solutions, one of the things we saw the greatest potential in is empowering our engineers, our employees, to build analytic skills right here at Exelon. So we developed an analytics academy approach, which gives them access to world-class curated content, which we have identified with our partner Coursera. And we built this to around three key things. One, increasing awareness of analytics so that everybody knows what AI is, what it means, what it could do for them. If they're interested, and a lot of employees are, in adopting analytics and actually building out analytics, we have an adoption program for them. And then lastly, for those who want to lead analytic projects by either being a project manager or actually being a sort of pseudo data scientist and actually working with data to deliver that for our use cases, we've been able to do that as well. We started the academy with 100 employees and have grown it to about 2,000 employees in the last 3 years. And we have graduated 300 plus employees through the adoption program. And through our leading program, we have actually solved 30 complex problems, which I'm very proud to say, traditionally we would have had to pay a lot of money to consulting companies to do for us. And we are getting those solved right here through the academy by our employees. So I just want to call that out that, as you think about AI, it's really important to invest in your employees and harness their excitement about analytics to solve the big problems for us. And as I end, I just want to give a shout out to our incredible, talented leaders, employees, and partners who have sort of made Exelon Analytics program, the academy, successful. And it's been a really personally enjoyable experience to me to see how Exelon is sort of growing in this space and becoming a leader. Back to you, Heather.
Yeah, thanks. I think that's a great story, and it's one component of culture that's really needed in an approach to get to enterprise-wide AI. And I know, Peter, you've been thinking about culture in this context. So can you share your thoughts there?
Absolutely. There are many things that you need for an approach or kind of successful adoption, but we found there are 5 elements that really distinguish the successful adoptions versus the others. And we have touched upon several of them today, but one of the 5 is actually the organizational commitment and prioritization. We have slightly touched upon that, but I would like to highlight it. And some of my colleagues put it, don't just sponsor, own. Sponsoring is nice. That shows interest. That's kind of a center of excellence. There's a digital lab. But owning means having the business having a skin in the game, having it as a targets, having it as in plans, because then they will commit resources, both money and people, and they will scrutinize versus those use cases that are being pursued will deliver value to them. So one of these 5 that we haven't yet touched today is this: don't just sponsor, own. Back to you, Heather.
Thank you so much, Peter. I think that's a wonderful, wonderful comment. And I'm just looking at our time here, and so I think it's time for us to wrap up our session. Like I said just a few minutes ago, I have really enjoyed our conversation and could honestly talk for hours with you guys. This has been great. I know I've learned so much. And I want to just take a minute here and reflect back to where we started. So I'm here sitting in EPRI's welding lab. I have our adaptive feedback welding experiment right over here next to me, where we're working really hard to advance this technology for the electric power industry. And as I'm thinking about this technology at a laboratory scale, I'm also thinking about that vision. So I'm thinking about a future where a nuclear power plant, for example, is being built using adaptive feedback welding that is welding pipes together throughout the plant almost at the same time, and using robotics to do all of that, of course. So in order to get from where we are today to that future vision, there's culture changes that are needed. There's adoption of enterprise-wide AI that's needed. It's an amazing future. I'm really looking forward to getting to that future. I'm really appreciative of the welding team that's working on this particular experiment as well. So I just want to wrap things up and just a big thank you to you, Peter, Rolando, Ankush, and Pedram. This was just a wonderful conversation, and I can't wait to talk to you more. Christine, I'm going to turn things back over to you now.
Thank you, Heather. So many great takeaways. There's no one size fits all solution, but utilities have to own it. That was one of the best ones that I heard, to get from that concept stage to the deployment enterprise-wide. It's a journey. It's an integration of use cases. It's training to those use cases. And the utility has to involve all the subject matter experts, the IT developers, the data scientists, all those who will be involved across the organization. And it is something that you have to own to implement enterprise-wide AI. Okay, I am between you and your last break, but first I do want to mention, if you missed any portion of our sessions from yesterday and today, they will be posted on our conference website, aiandelectricpower.com. Yesterday's are already there and available now, and today's will be posted shortly. They will also eventually be posted to EPRI's YouTube channel. So when we come back, we are going to jump into our final grand challenges. Until then, enjoy the full 30 minutes here to recharge and come back ready to roll up your sleeves and get to work. Thank you.